each other. This base a to the power y is x. Making sense?
Yes.
Last day also we were discussing about the same thing, that how can we convert logarithmic function to exponential, or maybe exponential function to logarithmic function if 2 to the power 3 is equals to 8. In terms of log, it can be written as this power will be the answer. Okay, this 2 will be log 8 base 2. Are you understanding?
Yes.
Okay, so this way we can convert logarithm from, okay, to exponent to logarithm. Now let's continue. So there are few properties of logarithm. I am going to show you the properties first. Then we will be drawing the, we will be talking about the graph and all. So the first property of logarithm is, if we are having log, okay, whatever be the base, just a second. If the base is, let's say a or maybe b, okay, if we are having the base as a b or maybe a or whatever, and if we are having m into n over here, that can be written as log m, okay, the base will remain same, plus log n. Getting it? This is one of the
Yes.
of formula we are having. Actually this all the formulas are coming from the law of exponent only. Okay, but proof I'm not going to show you because it will take time, and we need to use the formula. Nowhere it will be asked that from where this formula came. Okay,
Yes. Okay.
when we are having log, whatever be the base, if we are having m divided by n, that can be taken as log m minus log n. Making sense?
Yes.
Third rule, you can note down the rules as well. If we are having, let's say, log, whatever be the base p, okay, if we are having, let's say, a to the power m, that can be written as m log a. Yeah, the base will remain same. Okay, it was b, it will remain b. Making sense?
Yes.
For now I can show you the examples as well, that in case we are having log base, one more thing, when the base is e in the logarithm, when the base is e, this e is the same e whose value is 2.71 something. Okay,
Yes.
so when the base is e, we write this type of logarithm as a ln. Okay, and ln2 means the hidden base e is there, or maybe ln3 means it's the logarithm and the hidden base e is there, e. Making sense?
Yes.
And there is one more base. This is called the, this is called the natural log, and the common log. When the base is 10, when the base is 10, we call it common log. And whenever, just anytime anywhere, if you have seen log x or maybe log y or maybe log 10, okay, log, that means the base is 10, hidden base 10 is there. Getting it?
Yes.
But in your ncrt it is clearly written, this is the standard form of writing it in, okay, throughout this world, in all the curriculum, this way we manage writing. If we want to represent the base as a e, we write it ln, and if we want to represent the base as a 10, we can skip writing the base and we can directly write log. Whoever will see, they will understand the base is 10. Getting it?
Yes.
Okay, but in our ncrt it says that, but for now wherever we are okay, anytime anywhere log is written, log is written, okay, and if log x is there or maybe log y is there, By default we will be thinking that the base is e. Initially it has given you the warning that take the base as a e always over here. Okay.
Okay.
Yeah. So this type of logarithms, okay, with different bases exist, and these are the formula. I was talking about how to use the formula. So from now onward, I will not be writing the bases again and again. I'll write if you are having log of 2 into 3, you can write it as a log 2 plus log 3 according to the first rule. Making sense?
Yes.
Okay, hidden base e is there. We don't have to worry about that. Clear?
Yes.
If you are
E
having,
or 10.
okay, 3. Here in our NCRT, log means the base we will be maintaining as a e. Okay. I,
Oh,
yes.
okay. Yes, ma'am.
It is written in our NCRT that ln x will be written simply log x in the following exercises. That ln x can be simply we will be writing. Okay. Before this exercise, it is clearly mentioned that ln x can be written as log x in the following exercises. So if it is this type of already instruction is given, then we can take it whatever it says. Making sense?
Yes.
So log 2 plus log 3, this way we can use the first formula. The second formula can be used as if we are having log 2 by 3, that can be written as log 2 minus log 3. Making sense?
Yes.
Okay. The third formula says that if you are having log 2 to the power 3, then you can write it as a 3 log 2. Making sense?
Yes.
So we are done with the first three rules. I'll show you the next rules. Please note it down.
Okay. What is the headache?
Properties of logarithm. Properties of logarithm. Next rule says that log p base a can be, if you want to change the base, okay, suppose for any reason you want to change the base and you don't like this base a, you want to make the base as a b, then yes, you can make the base as a b. Okay, and you can write this one as a, this p base b, the b you have introduced. Okay, according to our choice we'll be introducing it in the questions. And the denominator can be written as log a base b. See, I wanted to introduce the base b, I wanted to change the base, maybe it will help me doing the calculation or whatever. I want to make this a as a b. Is there any way? So log says yes, there is a way. What you can do, just make the base as a b and write numerator and denominator. In numerator this p will be there, and in denominator your base whatever was there that will be there. Are you understanding?
Yes.
Okay, so this way we can change the base. Why we are talking about changing the base, I'm going to give you the example, but before that I will show you few more rules. Okay, so the next rule is log a base a is 1. Now I am going to show you the application for rule number 4. If we are having, let's say, log 2 base 3, and due to any reason or maybe proving the left hand side right hand side, okay, I want to make the base as a 2, I want to make the base as a 2. So logarithm says yes, you can make the base as a 2, you can make the base as a 2. Okay, just make the base
Okay.
as a 2 and then write this whatever was there along with the log, write it over here in the numerator, and whatever was the base previously, write that along with the log in the denominator. Making sense?
So we, yes, so we can change the base.
Yes, we can change the base, and this rule actually is called change of base rule. Actually the name
Oh,
of this rule is change of base rule.
okay.
And if you will ask me why we are doing so, so can you see the numerator became log 2 base 2? According to rule number 5, the answer will be 1 for the numerator.
Yes,
Okay, and the denominator, yeah, we will leave them as it is. Clear?
yes.
Okay,
2
so
log 2.
yeah, log 2 base 2 is 1. According to rule number 5, log a base a is 1.
Yes,
Okay,
okay.
so we are done. Let's start talking about the logarithmic function. First, note it down.
Done.
Now, any function which is in the form of, let's say, y is equals to log x base b. Here, output is y, input is x, and the base will remain fixed. Okay, if any function looks like this, we will be calling it logarithmic function. Now we understand that we can write it as a, in exponent form, we can write it as a b to the power y is equals to x, right?
Yes,
That is just for uh, our concept. If I am taking a log, for example, if I am taking a logarithmic function, okay, here the base b needs to be bigger than 1. Okay, base b needs to be bigger than 1, just like the exponential function discussion we had done in the last class. that if the base is smaller than 1, then there is a chance that we will land at complex number, right?
Yes.
Okay, negative to the power 1 by 2 or maybe 1 by 3, that will be imaginary, yes or no?
Yes.
Okay, that's why we are maintaining the base over here along with the log. Strictly we are representing that the base needs to be bigger than 1.
Okay.
Making sense?
Okay. Can it be equal to 1?
If we will take the base as a 1, then it will be 1 to the power, you take anything, anything. Okay, our exponential function, let me take our exponential function f of x was b to the power x, right?
Yes.
Where we said the base needs to be bigger than 1. If we will take the base as a 1, then it will be constant function,
Yes.
right?
Yes.
The way there we were not taking the base as a 1, here also we will not take the base as a 1. Making sense?
Yes.
Somehow these two are related with each other, logarithmic and exponential. Actually these two are inverse of each other. Okay, I'll show you. So here base needs to be bigger than 1, that is the first restriction.
Okay. We can write log base 10 as log, right? Just log.
Yeah, what?
We can write log x. Uh, no. Log base 10 as log, right?
Yeah, in general we write base 10 as a just log. In general, most of the mathematician, in most of the books, base 10 can be written as log, but before that it will be clearly mentioned, Miraj, that here base 10 will always be taken as a just log.
Okay.
Okay, and base e in general can be taken as ln, but before your exercise it will be clearly mentioned in the question that what writer is thinking about. Making sense?
Yes.
Here in our NCRT, wherever log will be there, clearly writer has written that whenever I am writing log, you have to take the base as a e. Making sense?
Yes.
Okay. So in your exam also, when the question will come, we will be going in the same manner. That according to our curriculum, when the base, nothing is there in the base and log is there, the base is e. Okay.
Yes.
Yeah. So any function which looks like this, y is equals to log x base b, where b needs to be bigger than 1. Okay, b needs to be bigger than 1. It's called logarithmic function. For example, you can take log base, you can take as a 2, and here you can just maintain x. This is one of the example of logarithmic function. Okay, another example you can create by yourself. Y is equals to log, okay, you can take x base 5. Making sense?
Yes.
Now we are going to see how, what will be the domain over here, what will be the range over here. Okay, how the graph will behave, just that. Okay,
Okay.
so when I am going to check the, let's say, domain and the range, so first thing first, we will be taking the exponential form, because that way we are more comfortable, right? That way we are more comfortable with the data. Exponential, the law of exponent, you are learning from very lower classes, right?
Yes.
Okay, so first thing first, we can write it as a 2 to the power y is equals to x. Yes or no?
Yes.
Now can you see the exponent y can be any real number?
Yes.
Okay, so I am going to say that in the logarithmic function, y is the output. Okay, y is the output, and output means range, right?
Yes.
Output means range, and the range can be any real number. Making sense?
Yes.
How I decided? By looking at this form. And what about x, the domain? So again, I will look at the exponent form which I have written in the circled part. And I will think what can be the x. So think about it. Whatever you will take as a y, okay? Whatever, -1, result will be positive. If you will take -2, result will be positive. If you will take 0, result will be 1, right?
Yes.
If you will take any number 3.5, result will be positive. And from here we came to the conclusion that x can be any positive number. It cannot be negative. How we decided? Just by looking at this format. Are you understanding?
Yes.
Okay, any positive number. Will x be 0? No, never. Even if the power is 0, okay, other side x will not be 0. Yes or no?
Yes.
Okay, so
Are
it
the
will.
two x different? Like,
Yeah, what?
are the two x different? Like, log 2 power x and 2 to the power y is equal to x.
No, it's same. I am trying to write this logarithm in the exponent form. How to write
Okay.
it in exponent form? So this y will go in the power of the base, and that will be
Yes.
equal to x. For example, if we are having log 8 base 3, not 3, is equals to 3, that means 2 to the power 3 is 8. Making sense?
Yes.
Similarly, if I have written in terms of x and y, you should not confuse. If you are having log x base 2 is equals to y, that means 2 to the power y is x. Making sense?
Yes. Yes.
And by looking at the second format, okay, the yellow colored circle part, we are deciding what can be x. And we came to the conclusion that x will be positive. X will be positive. Will it be 0? No. Making sense?
Yes.
Okay. So,
Hello.
yeah, domain of
Uh,
logarithmic function will be all positive real number.
okay.
Because no matter what will be in the power of 2, okay, what will be, whatever will be y, x will never ever be negative. Making sense, Miraj?
Yes.
Okay, so domain will be all positive real number, and range will be all real number. Clear?
Yes.
Again, I am summarizing all of it, that your logarithmic function will look like y is equals to log x base a. Any function which looks like this, you can call it logarithmic function. Now, here the
Okay.
base needs to be bigger than 1. Why? Okay, it is related to exponent, and due to that, the base needs to be bigger than 1. Any function which looks like this, we will be calling it logarithmic function. Here the base needs to be bigger than 1. Clear?
Yes.
Now we have taken one of the example of logarithmic function, that is y is equals to log x base 2. Okay, this is a function we have taken by ourselves. Okay, how we used to take the polynomial function, one of the example as a y is equals to x square, right?
Yes.
Similarly, here we have taken one of the example of logarithmic function, and we are trying to understand what can be the domain, what can be the range, and how the graph goes. But by looking at this logarithmic function, I am not getting clarity at all. So just for the clarity, I'll be converting it in the exponent form. Okay, we understand how to convert it in exponent form. So we will be converting this y is equals to log x base 2. This function I'm trying to convert in exponent form, and it will be 2 to the power y is equals to x. Now this will help me understanding what can be y and what can be x. You tell me if you are getting it or not.
Yes, I'm getting it.
Clear?
Yes,
That
so
y,
this is a formula.
yeah,
Like,
what?
do we have to memorize it or like there is a logic behind it?
This one, yes, you have
Yes.
to just take it as it is. Okay,
Oh,
that 2 to the power y, this 2 to the power other side number, that will be equals to x. Always we will be taking in the same manner. Always.
okay.
Yeah. So this way we can write it in the exponent form, and this is giving us clarity for identifying the domain and the range. Now, what about the graph? So we will check the graph as well. I am going to plot the graph of this function y is equals to log x base 2. Okay.
Yes, okay.
And for making the graph, what we do, we make the table, right?
Yes,
X and y we take. Okay. Now, if I'm taking randomly, I'm going to pick some numbers. If I'm taking x as a 2, it became log 2 base 2. And the answer is 1 due to the rules which you have noted just now. Are you understanding?
yes,
Okay. That's why at first I have shown you the rules, Miraj, and then I'm showing you the graphs and all. Next, if I will take x as a 4, so it will be log 4 base 2, right?
yes,
And this 4 can be written as 2 square. Yes or no?
yes,
And one of the rules says that if you are having the exponent like this, just take the exponent in front, right?
yes,
Check the rules. One of the rule is there which says that if you are having log p to the power n, no matter what is there in the base, if it is a or b or p, no matter what is there, this n can come in front. Making sense?
yes,
Okay, similarly, if we are having x as a 4, we realize this can be written in the exponent form, that as a 2 square, and then the power can be taken in front 2. After that the log will remain log 2 base 2, and according to rule number 5 this is 1. Yes or no?
yes,
Hence the result for when we are going to take x as a 4, our y is just 2. Are you understanding?
yes,
Okay, you can note down the solutions if you want to. Otherwise, if you are understanding, you can leave it. So when I am taking x as a 4, my y just ended up coming as a just 2 by using all the properties. Clear?
yes,
When I will take x as a 8, okay, x as a 8, just x, not log x, just x as a 8, and I'll put it in the function. So my function y will be log 8 base 2. Now this 8 can be written as 2 cube, right?
yes,
And then power can come in front. So this will be 3 log 2 base 2. And according to rule number 5, log 2 base 2 is 1. So it is 3 into 1, that is just 3. Making sense?
yes. This rule, like uh, the power coming in front, which rule number is that?
Which rule is that?
Like which number?
Yeah, I'm telling you. It is rule number 3.
Okay,
Okay, no matter what is there in the base, the exponent can come in front. Making sense?
Yes.
Let's continue.
Do we always have to bring the power in front?
If we are trying to simplify the logarithm, yes. Okay, taking the power in front will help us doing the simplification.
Okay.
When I took the when I took x as a 8, my y came out as a just 3. Making sense?
Yes.
When I will take x as a 1 by 2, we'll be having log, okay, y is equals to log x, that is 1 by 2 base 2, right, Miraj?
Yes.
Okay, and do you know 1 by 2 according to by using the law of exponent can be written as 2 to the power minus 1.
Yes.
So this 1 by 2, I'm going to write it as a 2 to the power minus 1. If you will ask me, why are we doing it? I want a proper value of y. And these are the rules, these are the properties which is helping us. Yes or no?
Yes.
Okay. So 1 by 2 can be taken as 2 to the power minus 1. Yeah, the base is 2. And again, the exponent will come in front and it will become log 2 base 2, which is just 1. Right?
Yes.
जब मैंने x के प्लेस पे 1 by 2 लिया तो मुझे y जस्ट माइनस 1 मिल गया. आ रहा है समझ में?
Yes.
Okay. And let me check what I can take. If I'll take if I'll take x as a 1, we will be having y is equals to log 1 base 2, right?
Yes.
और हमें यहाँ से समझ में नहीं आ रहा है कि y कैसे निकाले, राइट?
Yes.
ओके, तो मैं एक्सपोनेंट फॉर्म में लिख के एक बार देखती हूँ. कैसे लिखते हैं एक्सपोनेंट फॉर्म में? 2 टू द पावर y इज इक्वल्स टू 1. यस और नो?
Yes.
अब 2 का ऐसा कौन सा एक्सपोनेंट ले लें कि रिजल्ट 1 आ जाए? यहाँ से तो समझ में आ रहा है, राइट?
Yes.
राइट.
Yes.
तो
Zero.
0. क्लियर?
Yes.
अब हम ग्राफ को प्लॉट कर सकते हैं. हमने कुछ वैल्यूज x के ले लेके लॉग को सिंप्लीफाई करके रूल की हेल्प से y की वैल्यू निकाली है. जब हम सिंप्लीफाई नहीं कर पा रहे हैं तो हम सबसे पहले एक्सपोनेंट फॉर्म में लिख के चेक कर रहे हैं, क्योंकि हमें एक्सपोनेंट फॉर्म बेटर क्लैरिटी देता है. ओके. अब एक
Yes.
हमारा कोऑर्डिनेट है 2,1, ये रहा. दूसरा कोऑर्डिनेट है 4,2, ये रहा. तीसरा कोऑर्डिनेट है 8,3. इट विल बी ओके वेरी फार, वेरी फार, वेरी फार. ओके, एंड देन just 3. Okay, like this. And the next coordinate I have found is jab when x is 1 by 2, that means 0.5, y is minus 1, right?
Yes.
This is the point. And और एक पॉइंट मैंने लिया, जब x 1 है तो y क्या है? 0 है. तो ये, अब मैं इन सारे पॉइंट्स को जैसे ही कनेक्ट कर दूंगी हमें log x का ग्राफ मिल जाएगा. आ रहा है समझ में?
Yes.
ये जो log x का ग्राफ है ये हमेशा एक्स एक्सिस को 1,0 पे टच करके निकलता है. नो मैटर तुमने कौन सा बेस लिया है, बेस हैज टू बी बिगर देन 1. अगर तुमने बेस 10 ले लिया है और ये फंक्शन लिया है तो ये जो फंक्शन है इस लॉगरिदमिक फंक्शन का ग्राफ भी एक्स एक्सिस को 1,0 पे ही टच करके निकलेगा. एक बार सोच के देखो, जैसे ही हम x1 लेंगे y हमारा 0 आ जाएगा। क्यों? जैसे ही हमने x1 लिया, बेस कुछ भी हो, ओके, हम इसे इस तरीके से लिख पाएंगे that 10 to the power y is 1, yes or no?
Yes.
Yes or no?
Yes.
जैसे ही हमने x के प्लेस पे 1 लिया, y हमारा 0 आएगा, हाँ या ना?
Yes.
नो मैटर बेस में 10 है, 20 है, 30 है, 40 है, 50 है, जो भी है, हाँ या ना?
Yes.
ओके, तो तुम्हें हमेशा लॉगरिदमिक फंक्शन या स्टेटमेंट लिखा हुआ होगा कि लॉग फंक्शन का ग्राफ हमेशा 1,0 को टच करके ही निकलता है। तो इट्स ट्रू, राइट?
Yes.
मेकिंग सेंस मिराज?
Yes.
Okay, so that's it. We need to know only this much. Okay, I'm summarizing all of this because okay, maybe you are confused or because you are learning for the first time. So let me summarize everything properly now.
Okay.
हमने देखा कि कोई भी फंक्शन अगर ऐसा दिखे तो उसे हम लॉगरिदमिक फंक्शन बुलाते हैं, जो एक्सपोनेंशियल फंक्शन के साथ रिलेटेड है। इसका मतलब है a to the power y is equals to x, राइट?
Yes.
और यहाँ से हमने एक रेस्ट्रिक्शन है लॉगरिदमिक फंक्शन के साथ कि ये जो बेस a है दैट नीड्स टू बी बिगर देन 1, राइट?
Yes.
ओके, और हमें समझ में आ रहा है कि y। नाउ उसके बाद हमने डोमेन और रेंज की बात की, व्हाट विल बी द डोमेन, व्हाट विल बी द रेंज। इस फंक्शन को देखकर हमें समझ में नहीं आ रहा है डोमेन क्या होगा, रेंज क्या होगा। तो हमने एक्सपोनेंशियल वाले फॉर्मेट की हेल्प ली, और पावर को देख के मुझे लग रहा है कि आज तक मैंने किसी भी नंबर -2 वेट पॉजिटिव नंबर, आज तक मैंने किसी भी पॉजिटिव नंबर लेट्स से 2 और मे बी 2.5 और मे बी 3, ओके, एक्सपोनेंट में तो हम कुछ भी ले सकते हैं, कुछ भी। ओके, क्या अलाउड नहीं है मैथ्स में? जीरो इन द डेनोमिनेटर एंड नेगेटिव इनसाइड द रूट, ये सारी चीजें अलाउड नहीं है, बट दिस इज अलाउड। पावर कैन बी टेकन एनीथिंग, यस और नो?
Yes.
Can we take negative powers as well? Of course we can take negative powers as well. You have learned these things in the lower classes that the power can be negative and you can make it positive. Even if the power is negative, your result will not be negative, yes or no?
Yes.
Okay, so from here I got the idea that y can be any real number, and hence I am coming quickly and writing the range can be any real number. Got it?
Yes.
And now the what about the domain? So I am looking at the x value, what can be x, but this logarithmic function I don't know it really well. So again I am going back to exponent form and I am checking what can be x, what can be x. So I came to the conclusion that x will be always positive. Clear?
Yes.
Okay, will it be 0? So even though I'm taking the power as a, even though I'm taking the power as a 0, still x is 1. So after 0 it can be any real number, right?
Yes.
Okay, so the domain will be any number in between 0 to positive infinity, or maybe it will be any real number, positive real number. Making sense?
Yes.
पॉजिटिव रियल नंबर का मतलब ही होता है हम जीरो को काउंट नहीं कर रहे हैं। ओके,
Yes.
क्योंकि ना तो जीरो को हम पॉजिटिव में रखते हैं ना नेगेटिव में, दैट इज समथिंग न्यूट्रल, राइट?
Yes.
तो अगर मैं पॉजिटिव रियल नंबर बोल रही हूँ मतलब कि जीरो के बाद जितने भी नंबर्स है वहां से लेके इंफिनिटी के पहले तक, राइट? इंफिनिटी तक।
Yes. Yes.
आ रहा है समझ में डोमेन एंड रेंज हमने कैसे आइडेंटिफाई करा?
Yes.
अब हम ग्राफ की बात करते हैं। मैं पूरा अच्छे से क्लैरिटी यहाँ पे शो कर दे रही हूँ कि ग्राफ कैसे हमने प्लॉट करा है। मैंने एक लॉगरिथमिक फंक्शन का एग्जांपल लिया, बेस हैज टू बी बिगर देन 1, सो आई हैव टेकन वन ऑफ द एग्जांपल ऑफ लॉगरिथमिक फंक्शन, आई हैव प्लेस द बेस एज अ 2 अकॉर्डिंग टू द रेस्ट्रिक्शन। एंड ये इस लॉगरिथमिक फंक्शन का हम ग्राफ समझने की, तो हम जस्ट ग्राफ को देखने और समझने की कोशिश करेंगे। हो सकता है हमारे असर्शन रीजन बेस्ड क्वेश्चन में या फिर एमसीक्यू क्वेश्चन में ग्राफ से रिलेटेड कुछ पूछ लिया जाए। Okay, we must have proper understanding of this graph. तो हमें यहाँ पे सबसे पहले हमने एक टेबल फॉर्म करा, और यहाँ पे एक्स एंड वाई ऐसे ही हम किसी भी ग्राफ को हम ऐसे ही प्लॉट करते हैं। ओके, हमें ग्राफ प्लॉट करके कभी भी कहीं भी दिखाना नहीं होगा, ये सारी चीजें सिर्फ हम अपने अंडरस्टैंडिंग के लिए कर रहे हैं। ओके,
है।
नाउ इफ वी आर हैविंग log x base 2, randomly I am going to take few numbers for x, बट ध्यान से मैं ऐसे नंबर्स ले रही हूँ जैसे कि अगर log 1000 बेस 10 का मतलब होता है इस 10 का कितना पावर हम ले ले कि 1000 बन जाए, राइट?
यस।
ओके, तो 10 टू द पावर 3, यस और नो?
यस।
आंसर विल बी 3। और एक्सपोनेंट में भी हम वही चीजें कर रहे हैं कि 10 टू द पावर 3 इज इक्वल्स टू 1000, हाँ या ना?
यस।
ओके, तो मैं ध्यान से, यहाँ तुमने नोटिस किया या नहीं मैं बता रही हूँ, मैं ध्यान से, मैं सोच के यहाँ पे ले रही हूँ एक्स की वैल्यू कि 2 के पावर क्या कर दे कि 4 मिल जाए, मैंने एक्स के लिए 4 लिया। ओके, एंड इट इज रियली इजी टू अंडरस्टैंड कि 2 का क्या पावर कर दे कि 4 मिल जाए। आ रहा है समझ में?
यस।
फिर मैंने x इक्वल्स टू 8 लिया, क्यों? क्योंकि वहां से आसानी से हम निकाल पाएंगे कि 2 के क्या एक्सपोनेंट में ले ले कि 8 मिल जाए। आ रहा है समझ में?
यस।
फिर मैंने x इक्वल्स टू, ओके, मैंने क्या लिया, माइनस 8, आई हैव टेकन 1/2 ऑल्सो। ओके, here if you will write it like this, log, now यहाँ पे हम ऐसे सोच रहे 2 के एक्सपोनेंट में क्या ले ले कि 1/2 बन जाए, तो -1, हाँ या ना?
यस।
आ रहा है समझ में?
यस।
ये सारे इनपुट्स मैंने ऐसे ही नहीं लिए थे मिराज, मैंने सोच समझ के एक एक करके ऐसे ही इनपुट लिए थे जो मैं माइंड में ही कैलकुलेट कर सकती हूँ। हाँ, रूल्स से भी मैं दिखा रही थी, बट माइंड में भी कैलकुलेट कर सकते हैं अगर हमें बेटर अंडरस्टैंडिंग हो एक्सपोनेंट का तो। आ रहा है समझ में?
यस।
ओके, फिर मैंने यहाँ पे लिया log 1/2 x इक्वल्स टू, मैंने 1 लिया, और अब ऐसे सोच रहे हैं कि 2 के पावर में क्या ले ले कि 1 आ जाए, 2 के पावर में क्या ले ले कि 1 आ जाए, 0, हाँ या ना?
यस।
और ऐसे ऐसे करके हमें आउटपुट मिलते गए। ओके, मैंने तुम्हें लॉ ऑफ लॉगरिदम के प्रॉपर्टी से सारी चीजें दिखाई, बट डायरेक्टली भी हम समझ पा रहे हैं, राइट?
यस।
ओके, तो डायरेक्टली ये कर लेते हैं, जब प्रॉपर्टीज हमें यूज करना होगा तो फिर क्वेश्चन सॉल्व करते वक्त हम यूज करेंगे, एंड तब हम बेटर समझ पाएंगे प्रॉपर्टीज को। अभी के लिए डायरेक्टली कर लेते हैं कि जब मैंने x इक्वल्स टू 4 लिया तो हमारा एक्सप्रेशन कुछ ऐसा दिखने लगा कि 2 के पावर में क्या ले ले कि 4 बन जाए, तो y हमारा 2 निकल के आएगा। मेकिंग सेंस?
यस।
फिर जब मैंने x के लिए 8 लिया, कुछ ऐसा, तो हमारा एक्सप्रेशन, ओके, हमारा ये जो फंक्शन है कुछ ऐसा दिखने वाला है, और यहाँ पे 2 के पावर में क्या ले ले कि 8 आ जाए, तो 3। फिर जब मैंने 1/2 लिया x के लिए, तो फिर हमारा फंक्शन कुछ ऐसा दिखने लगा, और फिर वहां से हमें ये समझ में आया 2 के पावर में क्या ले ले कि 1/2 बन जाए, तो -1, आया ना?
यस।
और जब मैंने x इक्वल्स टू 1 लिया तो हमारा फंक्शन कुछ ऐसा दिखने लगा, और तब हमें ये समझ में आया कि 2 के पावर में क्या ले ले कि 1 आ जाए, तो 0। क्लियर?
यस।
और यहाँ से हमने सारे पॉइंट्स को लोकेट करके ग्राफ प्लॉट कर दिया जो कि कुछ ऐसा दिख रहा था। क्लियर? जो हमारा
यस।
ग्राफ 1,0 को टच करके जाएगा, नो मैटर व्हाट इज द बेस। क्लियर?
Yes. You are substituting the values of x and uh, to y, no, to y to the power x, right? Or,
Yeah, wait, there are two ways to find it. Either you find it like this, or you find it like this by converting it in exponent form. Okay,
okay.
so it will be 2 to the power y is equals to 4, so y will be 2, right?
Yes.
ओके, और ये सारी चीजें मैं माइंड में कर रही हूँ। मैं कैसे कर रही हूँ, मैं फिर से बताती हूँ। ये जो बेस टू है तुम्हारा, ये जो बेस टू है, द पिंक वन, कैन यू सी?
Yes.
इसके पावर में हम क्या ले ले कि 4 मिल जाए?
2.
2, आउटपुट विल बी 2। आ रहा है समझ में?
Yes.
सिमिलरली नेक्स्ट में बेस 2 है, इसके पावर में हम क्या ले ले कि 8 मिल जाए, तो 3, आउटपुट विल बी 3। आ रहा है समझ में?
Yes.
एंड सेम वे वी हैव डन ऑल द अदर्स इन आवर माइंड, वी हैव डन। अगर हम कॉपी पे लिख के एक्सपोनेंट में कन्वर्ट करके सॉल्व करेंगे तो हमें यही मिलेगा। यू कैन ट्राई इट, विराज। आर यू अंडरस्टैंडिंग?
Yes.
ओके, एंड दिस इज द ग्राफ। हमें सिर्फ इतना पता करना था, व्हाट इज द डोमेन, what is the range, how the graph goes. The graph is touching the x-axis at a point 1 comma 0, and the graph is the increasing function. Increasing means when we are moving from left side to right side, okay, the graph is going in the upward direction. Yes or no?
Yes.
And we are done with this function. Okay, we'll be solving the questions in the next class. I'll try taking the questions quickly, and you tell me what is the next chapter you want me to take after finishing it. Okay, and if possible, ask the team to increase the number of classes. Okay, I have also asked, but if you will ask, it will show that yes, you really need it, and accordingly they will arrange it. Okay.
Okay. By
Yes.
the way, I can take the classes early on uh, Fridays, Saturdays, and Sundays.
Yeah, so please, Miraj, connect with the team, because on daily
Okay.
basis I'm taking so many extra classes and everything has been designed by our team. Whoever says that they need classes, they are having syllabus to cover, and these are the things. They are getting more classes, and if any student is not asking the team again and again, they don't know. Okay, they don't know that if you need. So yeah, they are not arranging. So you have to tell them. Okay.
Okay.
And yeah, I'm keeping this much over here,